And Kyriaki, it's a great pleasure to have you here, and the floor is yours.
Thank you very much, Manuel. First of all, thanks for inviting me to be here. It's a pleasure to share with you some of my research findings and work. So with no further hesitation, I will start, and the goal is to, in 45 minutes, try and summarize 2 decades of epidemiological evidence on night work, ALAN, and cancer, including contributions from my group and research collaborators, and also reflect where science stands right now and where we should be heading. I have just one slide of a brief bio. I suppose most of you don't know me, so I thought it would be nice to introduce myself. So my first degree was in medicine, the University of Patras in Greece. And then during the economical crisis, I moved to Barcelona, Spain, where I did a master's in public health, and then my PhD in epidemiology in the Center for Research in Environmental Epidemiology. Afterwards, I did my postdoc jointly in the Medical University of Vienna and at the Channing Division of Network Medicine at the Harvard Medical School in Boston. And then eventually I settled in Vienna, where I'm an associate professor since 2019. And recently I'm also associated researcher with IS Global in Barcelona. And lots of the work I will be presenting today is a fruit of collaboration with different groups. My research has largely focused on circadian rhythm disruption and its impact on human health. First, I studied night shift workers and then expanded this research to the general population to evaluate sleep disturbances, chrononutrition, and how time of daily activities, including sleep and light, affects our health. And in recent years, I have also become very interested in the application of chronobiology in medicine, both in diagnostics and also therapies. And I have done some work trying to find the optimal time, for example, for drug or vaccine administration in order to achieve maximum efficacy and reduce side effects. But for today, we will talk about night work and light. And during my talk, I will mainly address these 2 research questions. So is there a link between night shift work and cancer? And is there a link between light at night exposure and cancer in the general population? And I will start with a brief introduction in circadian rhythms, assuming that the majority of you are familiar with this topic. So circadian rhythms are widespread in nature, but also in human biology, physiology, and behavior. This includes autonomic processes, such as, for example, our body temperature and blood pressure, hormone levels, such as, for example, melatonin and growth hormone will peak in the middle of the night, and even hundreds to thousands of genes will switch on and off during different times of the 24-hour day. And the basics of circadian rhythm. So circadian is Latin for about a day, which is the period of circadian rhythms. And biological rhythms are synchronized to the Earth's 24-hour rotation and environmental light-dark cycles. But they're endogenous. This means they persist in the absence of external cues, and they represent internal time. And also they are entrainable. This means that they are able to adjust to local times. So the circadian system is our timekeeping system that helps our body organize its functions and needs throughout the day and night. But how is it organized? So our master clock, our central clock is situated in the brain, but there are also peripheral clocks that are found in every organ and tissue and cell in the periphery. So the master clock receives primarily photic input from the sunlight, and through the retina of the eye sends the neuroendocrine signal to the pineal gland to produce or not produce melatonin. But there are other non-photic zeitgebers or time givers or synchronizers of our circadian system, such as, for example, the feeding and fasting cycle, sleep-wake cycle, and activity. And some of these non-photic zeitgebers are, as we know by now, are very important for synchronizing peripheral clocks, such as, for example, the clocks in the liver or the fat tissue. So when our exposure to zeitgebers, especially light and food, that are the ones that evolutionarily are more reliable, is timed appropriately and it's constant, then this helps our clocks stay in sync and healthy. And circadian disruption occurs, when our clocks receive conflicting external information about external cues. And so in that case, the central clock can be misaligned with the environmental light dark cycles, but also there might be different amounts of internal desynchrony between central and peripheral clocks. And the most common, perhaps also most severe cause of circadian disruption in the modern world is night shift work and also travel-related jet lag. So night shift work is a very common occupational exposure, and it has become to some extent an integral part of our 24/7 society. So it's more common among men, and it's widespread in a wide variety of occupational sectors. So it's no longer an issue just of the health sector. So traditionally the health sector was most affected, but nowadays it's very prevalent in the health sector, but also manufacturing, retail, service sector, and transport. And night shift work is a complex exposure. So it includes a large variety of round-the-clock work schedules, differing by type, speed, direction of rotation, length of shifts, number of consecutive shifts, and number of shifts per week. So it's not a black and white exposure. And we have come to learn a lot about circadian disruption by studying night shift workers in the real world. And this knowledge can then be applied to the general population who may also be exposed to some of these exposures that result from night shift work. So for example, night shift work involves exposure to light, to artificial light at night, but not only. It also causes changes in the sleep-wake cycle and sleep deprivation, circadian misalignment that was mentioned before, and also lifestyle and dietary changes, each of which may have downstream biological consequences. And it's also likely that different components of the shift work schedule, some of which I mentioned before, may result in different degrees of each of these changes or alterations or biological changes further down the road. So in the long term, each of these exposures or changes may influence physiology, safety, and long-term health. So in the short term, after a few days or weeks of night shift work, people feel sleepy. They may suffer from insomnia or fatigue. They may have irritability and gastrointestinal symptoms. All of these are also known as jet lag symptoms. But chronic circadian disruption over weeks or months and years has been linked to over 100 diseases, including affecting both physical and mental health, and including CVD, cardiovascular disease, metabolic diseases such as obesity and cancer, which are the main causes of death. And the longer your circadian disruption, your circadian rhythm is out of sync, the greater the risk of developing such a chronic disease. So today we will revise a little bit closer the evidence on relating night shift work with cancer. And it was first hypothesized back in 1987 by Richard Stevens that light at night may be a risk factor for breast cancer, based on early experimental studies that were showing that light suppressed pineal melatonin production. At the same time, there were several other experiments that were showing a relationship between melatonin and mammary carcinogenesis. However, it was not until 2001 that we have the first epidemiological evidence of a link between night work and cancer. And here in this table, you can see the summary of the 3 studies that were all published in 2001. And these were 2 case control studies and a prospective cohort study. So these are different study designs in epidemiology. And all of them were suggestive of an increased risk of breast cancer in night workers compared to day workers in these 3 studies. And there were 3 additional studies on flight attendants, radio and telegraph operators that were not explicitly looking at shift work, but they were also finding some associations with breast cancer. So the Neuroscience studies were the first prospective cohort that showed evidence of a link between night shift work and breast cancer. And this was the 2001 report, which was led by Eva Schernhammer. And she used data from the Neuroscience study 1. So these are 2 different cohorts. So she used data from Neuroscience 1 and included 80,000 women that were female US registered nurses in 1988 and they were asked a question regarding how many years they had worked rotating night shifts with at least 3 nights per month. And then these women were followed for 10 years until 1998. And over this 10-year follow-up, 2,400 cases of breast cancer were recorded. And these were included in this first report. Obviously, when you have a prospective cohort and you follow people over time, you will have many reports on even on the same disease endpoint, adding, for example, follow-up years, or then looking into them to other endpoints. So this was the very first report, and it was based on this question that I just described. In nurses 2, they introduced updates of the exposure. So every 2 years, nurses were asked to update information on their exposure to night shift work, and therefore exposure could be updated over time, and also cumulative estimates of cumulative exposure could be calculated. Here you can see the summary of the different analysis on different endpoints, cancer endpoints within the NERSICEL studies 1 and 2. And as you can see, different associations were demonstrated not only with breast cancer, but also other cancer sites, including endometrial cancer and colorectal cancer. And the risks increased always in the top category of exposure, sometimes after 30 years or 20 years of exposure, and not before. And of course, the strength of this study and similar studies is its prospective design, which means that the exposure is assessed and recorded, although it's self-reported, but it's assessed before any outcome occurs. And another advantage of this cohort is the long follow-up, but the disadvantage was the fact that, for example, in Nurses 1, there was only one question included, and there was no additional information about the shift schedules, so no additional metrics were assessed. So this first study and a few others, so a total of 8 epidemiological studies, informed the first IARC, International Agency for Research on Cancer, WHO evaluation of the carcinogenicity of night shift work. In this, which is part of the monograph programs, and in these programs, experts on a topic, they gather together and they sit down and evaluate the totality of the evidence across different fields. And typically these fields include experimental studies in animal experiments, but also humans, and also evidence from epidemiological studies. And in 2008, there was a first monograph on night shift work that concluded that shift work that involves circadian disruption is probably carcinogenic to humans, based on sufficient evidence from experimental animal studies and limited evidence from epidemiological studies showing positive association between night work and breast cancer. And the strongest evidence came from the NERSICEL study cohort back then, and the working group back then also noted the variability already in exposure definition and assessment across different studies. And also they noted that the information was rather crude in relation to night shift work. For this reason, they called an exposure workshop. They organized an exposure workshop, which was unique in the history of the IARC, as far as I'm concerned. And the goal was to reach a consensus among experts on how to best define and assess night shift work in future epidemiological studies. And the group identified several domains to be captured in future studies, as well as variables and how to measure the impact of circadian disruption for each of them. And as you can see, the domains include things like exact work hours, be consistent in your definition, so as at least 3 hours between midnight and 5, capture years, but also the intensity matters, or the type of shift work, and so on. So all of these aspects need to be considered as well. And some of these recommendations we try to apply in the MCC Spain study. This was a multi-case control study in Spain that recruited 10,000 cancer cases and controls from 2008 to 2014 in different regions of Spain. And I happened to be involved in this study early on. So what we did here, we did face-to-face interviews with all the participants, where information on a wide range of information was collected, including residential histories, medical history, lifestyle, socio-demographics, diet, but also we had the opportunity to assess the lifetime occupational history of each of these participants for all jobs held for at least a year. And of course, this is now a reverse study design. So you start from the disease and you go back in time to track the exposures back then when they occurred. So these studies are more prone to recall bias, as people have to retrospectively recall and you have to reconstruct their exposure history. And half of them have a disease and the other half are healthy controls. But we were able to ask specific questions for each of the jobs that people held throughout their life for at least a year. And so we asked things like, what type of job was it in terms of shift type? When did you start working and when did you end? How many nights did you work per month, and so on? And so we were able to go into to assess the shift work metrics. That was what was missing from the literature. And again, I'm just showing you the summary of our findings, and the results were similar to the cohort. So essentially, night shift work was associated with increased odds for cancer in both sexes for all three tumors. These are common tumors: breast, prostate, and colorectal cancer in men and women. And risks were higher, especially after long-term or more intense exposures. The estimates were somewhat lower compared to the cohorts, but still considerable, given the high prevalence of both the exposure and the diseases we looked at. And we had the possibility to not only look into night work, but also into the shift work domains, including the shift work type. So we compared permanent to rotating and the metrics. And risks were increasing with the duration and the frequency, but in general were comparable between rotating and permanent night workers, at least for breast cancer. And what was quite interesting is that we found a much higher risk for aggressive prostate tumors, which are those that are more high risk and more relevant from a clinical perspective. And we also found evidence that prostate and estrogen receptor positive tumors were linked to even higher odds of breast cancer in night workers. We later participated in a pooled analysis of the 5 case control studies on breast cancer around the world with detailed assessment of night shift work and lifetime occupational histories that was led by Émilie Cordinat in CERN in France. And this is a good approach when the variability in the exposure assessment across the studies is high. What we did here is first of all, we used the common definition for night shift work as recommended by the Stevens et al. Paper, and all the covariates were harmonized across studies. And so were the exposure. So this study also had a greater power because it included over 6,000 breast cancer cases and around 7,000 controls, making it one of the largest studies back on that day with individual level information on night work and breast cancer. And basically what we found was that the intensity of night shift work matters as much as duration, and suggested also that the risks among premenopausal women were higher. This finding is slightly in contrast with some of the cohorts, but it has been argued that some of the differences between cohorts and case control studies right now may be due to the different level and detail of information we have in terms of exposure assessment. So the exposure misclassification is higher as we have it right now in cohorts and case control studies. However, this question remains open. But the question of evaluating the relevant critical time windows of exposure, such as looking exposures before or after the first birth, and confirming whether the risks for premenopausal breast cancer are truly higher, is one of the things that future studies will have to address. In the study, we also found that the risk of premenopausal breast cancer increased in schedules with more than 3 nights per week, and then with more years of exposure, indicating a potential threshold for frequency and dose response with duration of years of night work history. But again, this needs confirmation and replication and is extremely important when it comes then to recommendation and policy regarding safe and healthy work hours. And last, we also found some evidence that the risk declined after quitting shift work or with time since last exposure. And this has also been suggested by some of the cohort studies, and it's, in my opinion, like with smoking, is a relevant and important issue to be further investigated. So how fast and how quickly does the risk go away after leaving night shift or after quitting night shift work? So all of that led us to the second IARC classification in 2019, when IARC re-evaluated the carcinogenicity of night shift work and reached the same conclusion. So night work is probably carcinogenic to humans, with the same group category, and extending this classification to prostate and colorectal cancer, largely based on some of the work we did in the two groups. So today, the most consistent epidemiological evidence for the association between night work and breast cancer comes from case control studies rather than cohorts, and particularly the pooled case control study that I just mentioned. Now you may be wondering, we have more studies, especially for breast cancer, but why same classification despite more studies? So the group concluded that overall there were positive findings, but there were also some inconsistent results. And that chance, bias, and confounding could not be entirely ruled out. And here are some of the issues that some of the studies were suffering, not all of them, but several of them. And the key one, at least from my point of view, is the issue with information bias and exposure misclassification. So while we need more high quality exposure assessment studies, we don't need more low quality exposure studies. And by that, I mean, we don't need more studies saying ever, never, or current night work. We need to understand better the exposure in order to make sense of it. But another thing that the group noted was that there is a need and a lack and a need of more mechanistic studies in humans. So studies measuring biomarkers, circadian biomarkers, but also chronic disease risk biomarkers. I will get back to that. Now, some other open questions. So what about susceptible groups of workers that may tolerate shift work better or worse? So these are some of the questions we are asking ourselves in more recent years. And it has been hypothesized that some of these characteristics, chronotype, sleep, diet or meal timing, and genetic makeup may affect tolerance to night shift work differently and could impact cancer risk differently. Up to the second IARC meeting, most studies lacked statistical power to conduct such analysis, subgroup analysis or interaction analysis, and future studies should address those issues. In relation to chronotype and sleep problems, we've done some work, and my take so far is that chronotype is not that promising in the sense that we are finding evidence that both morning and evening night workers at an increased risk of cancer, and we are certainly not finding evidence that evening chronotypes are protected, for example, which was something that was hypothesized, but we are not confirming this hypothesis. I find the sleep area more interesting, and we do find evidence that co-exposure to night shift work and sleep disturbances increases the risk not only of fatigue and injuries, but also chronic diseases such as cancer. And Isabel Santonja is doing some further work on evaluating which of these are key mediators in the link of night work and cancer. And together with Camila Sal and Ana Espinosa from IS Global, we're looking into interactions between night shift work and diet, different types of diets and chrononutrition, as well as genes and polygenic risk scores, both for cancers and for different phenotypes such as chronotype, sleep problems, sleep duration, and circadian genes. And some of our preliminary findings here show promising results. For example, for the diet analysis, we're finding evidence that diets with a higher anti-inflammatory potential may offset some of the increased cancer rates that we see within the MCC Spain study. And we're also finding some significant gene-environment interactions between polygenic risk scores and night work exposure for the polygenic risk scores that are created for the circadian phenotypes, but not for those people who have genetically high risk of cancer. And I will now talk a little bit about mechanisms, and I mentioned previously that the IARC also noted a lack of mechanistic evidence in human studies. And here you can see a theoretical framework of possible behavioral and biological mechanisms by which shift work may cause cancer. So we mentioned some of them. So night shift work leads to exposure to artificial light at night, often overnight, and changes in sleep-wake cycles, circadian misalignment, and mistimed diet and activity patterns that could all lead to an increased risk in cancer. And all of this may happen through a number of interrelated biological mechanisms, including suppression of nighttime melatonin production, metabolic changes, alteration of gene expression in circadian genes, but also changes in sex hormone levels. And some of these are relevant, especially for hormone-dependent cancers. And understanding the mechanisms and applying such biomarker-based approaches in population studies will help us, is helping and will help us more in the future advance the knowledge on pathways. And we started conducting such studies a while ago. So back in 2012, we conducted one of these first small studies, biomarker-based studies in real-life shift workers. We were also measuring light in shift workers back then, but eventually this has led to larger efforts, EU-funded projects in more recent days, namely the E4 and Shift to Health project. And I will just briefly refer to this type of studies and what sort of findings we get out of them. So back in this first study we conducted in 2012, we recruited 117 night and day workers from 3 different industries, and we asked them to collect all natural urine voids over 24 hours. And we measured 6-sulfatoxymelatonin, which is the main metabolite of melatonin in urine, as well as 35 endogenous steroids, and applied cosine analysis and compared the cosine curves between day and night workers. And as you can see, for example, in this old study, we were finding that 6-sulfatoxymelatonin production was displaced by 3-hour phase delay among night workers, but also the rhythm was flattened with lower levels of melatonin compared to day workers. And we were finding evidence of a small phase delay indicating a partial adaptation to these shift schedules, which actually were 3 different shift schedules. And I'm not showing it, but we were also finding that higher light intensity during the night shift measured by luxometer, so light loggers that were placed on the shoulder level, were also associated with stronger effects in terms of suppression and phase delay. And we were also reporting higher levels of androgens and progestogens in night workers compared to day workers. And these were very interesting to us back then because we had a major focus on breast and prostate cancer. And evidence like this was lacking, especially in male night workers. Then, to partly overcome the issues with inter-individual variability in circadian timing between workers, and because we were comparing night to day workers, sometimes with different tasks, different people, but also to account for all the different influencing factors, we conducted a second study, the hormone study, where here we studied 51 male rotating night shift workers from a car company that worked on a slow backward shift schedule. So this means every 3 weeks, workers were rotating from the night shift to the morning shift and the evening shift. And these backward shift schedules are associated with very bad sleep and lower alertness and a lot of health issues compared to the clockwise rotation. So these workers, in addition to the urine, they also provide blood samples before and after each of the night shifts, and they participated twice, after 3 weeks of night shift and after 3 weeks of a day shift. And they were also wearing an active watch, and we also recorded light using the luxometer. And I'm not gonna go into the details because these are also published. All the analyses were published, and here comparing within individuals, we also found association patterns indicating a greater phase delay of melatonin because these workers were working many more consecutive nights. So here we had evidence for a much bigger shift adaptation to the shift, Despite that, many of the immune markers were immunosuppressed, and we also found evidence of metabolic alterations across different across the top 20 metabolites that we included. And for more details, you can refer here. I will need a separate talk for this, so just wanted to briefly mention. And one more question we had within this study was, what about adaptation? And what are the predictors of adaptation? And so we also evaluated shift work adaptation based on the overlap of the melatonin production in the sleep episode as recorded by actigraphy. And then we looked into the predictors of both the adaptation to the night shift and the day shift. And basically, we found that during the night shift, later chronotype and more light exposure during the night shift were associated with worse adaptation, while longer duration was associated with better adaptation. And for the day shift period, a later bedtime was associated with worse adaptation, while longer sleep duration was associated with better adaptation. So this was a small sample. Some of these things make sense, others not entirely. So some are in line with experimental evidence and others are not. But this was kind of a first exercise of us trying to replicate and understand in the real world how does adaptation work and what are the important drivers of shift work adaptation. And we definitely need replication of this in larger studies. And as I said, this area of research has now become central for me, and currently I'm involved in these two EU-funded projects, the E4Night study, which is led by IS Global, and the Shift to Health study, which is led by us here in Vienna. And both of these are multi-biomarker studies across several EU countries aiming to characterize different biomarkers for disease risk and going beyond melatonin hormones, so hormones, which was previously our main focus, and extending to other biomarkers, including lipids, glucose metabolism, chronic inflammation, and also gut and oral microbiome in the Shift to Health project. And I will just say a few more words for the Shift to Health project. So we are currently aiming to recruit 1,000 night and day workers in 5 countries. We're halfway through the recruitment, and our aim here is to compare dietary, lifestyle, and pre-obesity risk markers between night and day workers from both the industrial and healthcare sector in 5 countries, including Austria, Germany, Denmark, Netherlands, and Poland. And here the main biomarkers of interest are pre-obesity markers, but to a large extent, many of these markers are overlapping with many of the markers we evaluate for other chronic diseases, metabolic diseases and cancer. So such as, for example, chronic inflammation or metabolomics and the gut and oral microbiome. And within this study, we're also doing a nested mechanistic study where we also have participants participate twice. So we're doing both between subject and within subject comparisons. So to summarize the first part, is there a link between night work and cancer? Night work is a probable carcinogen for humans for the 3 most common cancer types in men and women, namely breast, prostate, and colorectal cancer. New evidence is linking night work to biomarkers, which relate closely to many chronic diseases, including cancer. And there is a need for more high-quality epi-cancer studies with high-quality exposure data and biomarkers and some open questions, but we know enough to act. So we need to be working with occupational health policymakers and stakeholders and implement control measures such as cancer prevention at the workplace and screening and interventions, as well as circadian and sleep hygiene educational programs for workers, but also their employers. Sorry. And now for the last 10 minutes, I will move on to the second research question, which was, is there a link between light at night exposure and cancer in the general population? And it's one of the next natural question, I guess. Does this affect only night workers, or does it also affect all of us, given it's estimated that 99% of the US and the European population live under light polluted skies, and there is more and more excessive misdirected use of artificial light at night. So it is quite surprising to me how little attention, how little investigation light at night has received so far. compared to other environmental pollutants, at least in epidemiology, such as, for example, air pollution or noise. So there were several comparative evaluation of spatial variation between at county level, so aggregate level incidence of cancer and light, so which led to evaluations using individual light data, like the one I'm presenting here. This is from the Nurses' Health Studies 2, where residencies were geocoded and then linked with satellite light data, showing that nurses, and you can see here the addresses of the nurses throughout the US. So this analysis led by Peter James showed that nurses who lived in neighborhoods with higher levels of light pollution were at an increased risk of breast cancer when comparing the top quintile of the exposure to the lowest quintile of the exposure. And these estimates were adjusted for individual level factors and also some other urban related factors such as air pollution, for example. And they were robust despite the adjustments. However, the satellite sensors used by this study, but also many of the other existing studies, was colorblind, so it didn't capture the spectrum of the light, the wavelength, the wavelength of the light, or the spectrum of these emissions. And this is critical, as we know that many of the impacts of artificial light at night are sensitive to the spectrum of light, including melatonin production. So in the MCC Spain study, outdoor ALAN was also analyzed using images from the International Space Station that were available back then only for Barcelona and for Madrid for relevant time periods. And this included data of remotely sensed upward light intensity and blue light spectrum information for each of the geocoded longest residence reported by each of the MCC Spain participants. And again, here, when comparing the highest to the lowest tertile of exposure to outdoor ALAN in the blue light spectrum, showed an increased risk in both breast and prostate cancer. And then for indoor ALAN, self-reported questions regarding the level of bedroom brightness levels were used, and also pointed to higher odds only for prostate cancer. However, the magnitude of these effects is rather big compared to the estimates that we showed you before for night work, for example. So I would say, given we don't know exactly what this satellite outdoor ALAN represents, I think these estimates need to be interpreted with caution. And then Anna Palomar, who was previously doing her PhD in the group, and then she left to do her postdoc, she did the systematic review and meta-analysis of on ALAN and cancer risk. And she included observational studies that evaluated the association between outdoor or indoor ALAN and any cancer type. She searched different databases, and she did the quantitative synthesis for only breast and prostate cancer due to the limited information for the other sites. And out of the 29 studies included, the vast majority, so 21 of them, focused on breast cancer. There were only 2 or 1 reports for the other cancer sites, and the great majority focused on outdoor ALAN. And also the majority used DMSP satellite data. And so here you see the results from the meta-analysis. So exposure to higher levels of outdoor ALAN was associated with a higher risk of breast cancer. And most of these studies on outdoor ALAN had used satellite images with a very low resolution, so up to 5 kilometers. So these were the DMSP satellite images that I mentioned before, and did not include any information on the color of light. And then the results for indoor ALAN were weaker. Here we go. And they were borderline significant. And as I mentioned before, most of these were self-reported They were highly heterogeneous. Many of them were not validated, and therefore different levels of exposure misclassification are to be expected in these estimations. And here are the results of the 2 studies on prostate cancer, and then one of each of the other sites. In case, in the sake of time, I will just move on. So one question we had is, how does type of satellite data chosen influence the effect estimates? And here we can see the different satellite data that has been used in different studies. The majority were here with DMSP that has a low spatial resolution, but also it's colorblind, and the saturation of images that affects the estimates. And then VIRS has a better resolution, but it's also colorblind. And then the ISS, which was the only other satellite image used, has much better spatial resolution, but it was only available for specific cities. Now things are, I know they're fast changing. There are new satellites that give also spectrum information across covering nationwide areas, but this was at least what was there when we did the review. And so Barbara compared the different satellite types for the MCC, linking them to the MCC data, and she examined the association between the association of ALAN and colorectal cancer risk using the estimates from the 3 different satellites that I just mentioned. And so basically, she found a very poor correlation between the 3 sources of visual ALAN data between DMSP, VIRS, and ISS. And also the cancer risk estimates varied greatly depending on which satellite type was chosen, which is problematic and not good. So I will sum up this second part. So as far as today, residential outdoor ALAN is associated with breast cancer risk, but more research using better characterization of ALAN exposure is needed. Future epidemiological studies on ALAN and health should focus on newer technologies with light spectra-based estimates and limit the use of low spatial resolution data. Validate outdoor and indoor ALAN measures, and consider assessing personal ALAN exposure with wearable light loggers. And doing this is important, has to be fast, and it's urgent, as ALAN was identified as an agent for evaluation by the IARC monographs with high priority for the next 5 years, advised to be reviewed in the later half of the 5-year period. So to sum it up, night work is associated with risk of several cancers. Preventive action should be taken already. Improved exposure assessment methods used to assess the complexity of night work and ALAN in EPI studies. Better quality studies are needed. And mistimed exposure to light, food, sleep, activity may have long-term health consequences relevant for public health. So we need to be raising awareness about circadian and sleep health and potential impacts of ALAN on human health. And I will say thanks to the many contributors, collaborators, research groups, and funding agencies. And I just want to briefly invite you to check the website of the Working Time Society, where I'm a board member and also I'm the secretary of the ICO Scientific Committee on Shift Work and Working Time. So please check out our activities, follow us in social media, and join us in Brazil if you can in November. The registration is now open. Many thanks, and happy to take questions.